Hello friends, today we are going to continue our GATE PYQs on propositional logic in discrete mathematics. So we have already completed 9 questions in the previous 2 videos. Now next 4 questions that we are going to do today are as follows. Okay. So friends, we have to do this question. Consider the following expressions. First false, Q, second Q, third true, fourth P or Q, fifth is not Q or P. The expression number of expressions given that are logically implied by P and P gives Q is, we have to tell इनमें से कितने जो expression मिला के हमारे इसको imply करते हैं. ठीक है, तो हम ये start करेंगे. We will start with the premise. This is the, we are given with this premise P and P gives Q. तो we will simplify this premise. P gives Q. इसको हम लिख सकते हैं not P or Q. Okay. So P and not P or Q. Using distributive law, it is P and not P or P and Q, but P and not P. This will lead to false. False or P and Q. It implies P and Q. So the premise is logically equivalent to P and Q. So it means P and Q both needs to be P and Q needs to be true. Okay. So step 2. What we will do? This was step 1. We simplified the premise. Step 2. We will check with the expressions are implied. An expression is logically implied if it is true whenever P and Q is true. अब हमें इनका implication check करना है. So first में दे रखा है false. False तो हमारा never implied. Never true, so never implied. Second, Q. Q is true under P. Q is true under P and Q. Therefore, implied. This was not implied. Then, third, true. True is obviously implied. Fourth, P or Q. P or Q में, if both P and Q are true, then P or Q are implied. Fifth, not Q or P. When Q is true, not Q is false. But P is true. Okay. So false plus true जो होता है वो होता है true. So expression is true. ठीक है, so this is implied. Okay, so all this you can say expression 2, 3, 4, 5. All these are implied. So we can say that the number of expression given above the logically implied this is 4. Answer is 4. Okay. So next come to the next question. So we are having next question as let PQRS represent the following propositions PQRS. The integer x greater than 2 which satisfy this one is. So what we will do, we will write this expression as simplify it. Okay, so not P gives Q and R S. Okay, so first P gives Q. It is not P or Q. Using De Morgan's law, not of A and B is not A or not B. So here we are having not of A or not of B is R or R N N. Sorry, S. Okay, P. Here we have already simplified upwards. Normal P and Q, R and S. This becomes P and not Q, R and S. So this was our first step. We just written our expression like this. Okay, now analyze both parts. Okay, analyze this part as well as this part. Okay, first part P and not Q. So P belongs to this, P is this, Q is this. Okay, so out of this P is, you can say 8, 9, 10, 11, 12. Q is not a composite number. So that means Q is not composite. So it is prime. So both we have checked. So this part is true only for 11. कि जिसमें हमारा इनमें से भी है और नॉट कंपोजिट दैट मीन्स प्राइम है. तो प्राइम है तो हमारा एक ही नंबर प्राइम है जो कि है 11. ओके, एंड देन वी आर हैविंग R and S. So perfect square and prime. Okay, so no such number exists. No such number exists. Like 4 is a square, but not prime. Okay, so final answer, step 3, that we are having end of this and this, that is 11 is the answer. Okay, so coming to the next question. Okay, next question is एक रूम है जिसमें टाइप 1 और टाइप 2 दो तरह के पीपल हैं. तो हम एक बात कह सकते हैं कि टाइप 1 पीपल ऑलवेज टेल ट्रूथ. दिस इज गिवन. एक बात ये कह सकते हैं टाइप 2 पीपल ऑलवेज लाई. ओके, तो आपने फिर ये बोला है कि द रिजल्ट ऑफ द टॉस इज हेड इफ एंड ओनली इफ आई एम टेलिंग द ट्रूथ. ओके, तो इसको हम लिख लेते हैं H and this is T. So H is if and only if T is there. Okay, type 1 always tell truth, type 2 always lie. We have here upon you can say tossing the coin, you are having the result of the toss is head if and only if it is telling truth. ओके तो अब हम दो केस बनाएंगे यहाँ पे. केस 1, ओके, पर्सन इज टाइप 1. पर्सन इज टाइप 1. तो टाइप 1 ऑलवेज ट्रूथ बोलते हैं. देन टी इज ट्रू. तो statement becomes H true becomes H. So coin must be head. Consistent. Now case 2. Person is from type 2. Okay, type 2 is liar. Then जो T है वो है हमारा false. So statement becomes H gives false. That means आंसर जो आएगा यहाँ पे वो आएगा not H. So statement claims a tail, but liars speak false. But liars always speak false. So liar must speak false. So actual result may be head. Okay, must be head. So in both the cases, type 1 or type 2, the final coin result is head. So the result is head. Okay, so B, C, D are incorrect and option A is. So when the result of the toss is head if and only if I'm telling truth. So in this case the person is telling that when he is telling the truth he must be having this H as the head, and as it is consistent in this case, and in this case too also person is okay consistent when we consider it T to be false and not H will appear, and not H will appear means tail is there. Okay, so H is true. Okay, so the result is head. Now next question. Okay, so we are having, consider the following two statements S1 and S2. S1 को हम ले लेते हैं जो यहाँ पर C से हम ले लेते if the candidate is known to be corrupt then he is not elected. If a candidate is kind he is elected. Which of the statements S1 and S2 are logical as per sound as per inference rule of the logic. Okay, तो हम यहाँ पे ऐसे ले लेते हैं. Let C is candidate known to be corrupt. Okay, K is kind, E is elected. ठीक है, अब S1 लिखो. S1 हम if a candidate is corrupt then he will not be elected. Not be elected इस तरह से लिख सकते हैं. ऐसे ही हम S2 लिखेंगे. If a candidate is kind he is elected. ठीक है, अब स्टेप 2 में लॉजिकल implications को कंबाइन करो. from S2 step 2. This was step 1 above. Now this is step 2. From S2 K gives E, but from S1 C gives not E. तो अगर कोई kind है तो elected होगा, और अगर कोई corrupt C है तो elected नहीं होगा. ओके, सो इसका मतलब है दोनों एक साथ ट्रू नहीं हो सकते, क्योंकि ई एंड नॉट ई एक साथ पॉसिबल नहीं है, पॉसिबल नहीं है। तो हमारा एक साथ पॉसिबल कैसे होगा? व्हेन के गिव्स नॉट सी। ओके, मतलब कि काइंड है तो नॉट करप्टेड है। तो अब स्टेप 3 में हम चेक करेंगे कि ये वाली स्टेटमेंट कब पॉसिबल हो पा रही है। तो अगर कोई पर्सन इज नोन टू बी करप्ट, ही इज काइंड, तो करप्ट है तो काइंड है, ऐसा तो नहीं होता, तो ये वाला रॉन्ग है। देन इफ अ पर्सन इज नॉट known to be corrupt, he is not kind, not corrupt, not kind, this is reverse implication, this is also invalid. If a person is kind, he is known to be corrupt, this we have already proved, so we are saying we will go with the option C. And if we will see at the option D, if a person is not kind, he is not known to be corrupt. Not kind, not corrupt, contrapositive नहीं बनता। ठीक है, तो ये हमारा ऑप्शन सी है इसका आंसर। So that's all for today's guys, and subscribe my channel for more videos. Thank you.